So, which have obtained a place and have some mass, it is matter. Then properties of the particle. So, the matter is made of particle, and there are intermolecular attraction force. So the kinetic energy is increases with temperature, and attraction is decreases with temperature. Then state of matter, so solid, liquid, and gas. Solid, so closely packed, definite shape, definite volume, negligible compressibility, negligible diffusion, highest attraction force, negligible kinetic energy, and isotropy, anisotropic, and highest density and hardest. Then the liquid, so liquid have the less closely packing, indefinite shape and definite volume, slight compressible and moderately diffusible, and moderate attraction force, moderate kinetic energy, and isotropic, and moderate density and moderate hardness. And gas is weakest packaging and indefinite shape and indefinite volume, highest compressibility, highest diffusion, minimum attraction force, and highest kinetic energy, isotropic, negligible density, and not hard. Then the advanced stage of the matter. So fourth stage is plasma. So plasma, the most abundant metal in universe, not naturally found on Earth. It is highly ionized. So sun's ray collection in ionosphere and star twinkle shine. Then the Earth application. So iron in the gases, electricity induced glow and used in neon bulb and tube lights. Then the Bose Einstein state or condensate fifth state. It is the super fridge discovered by Bose and Einstein, and super atom. All atom collected at minus 273.15 degrees Celsius and continuous wave emerge. Low temperature, low kinetic energy, high attraction and atom collected. Then come the solid state details. So type of solids. So crystalline solids, so they are arrangement long range order and fixed temperature and of melting point. They have negligible compressibility, symmetrical, and isotropy, anisotropic. They are two solid. Example: NaCl, quartz, iron, and copper. Qualification by interparticle force. So, molecular solid, ionic solid, metallic solid, and covalent solid. So, molecular solid are the constitute are the molecules bond, London, non-pair, dipole, polar, and H bond, and natural soft, and condensivity insular, and melting point low, and H2 I2 non-polar, SCl and SO2 polar, and H2O H bonded. Then the ionic solid, so constitute ion and bond, electrostatic and hard but brittle, conductivity insulators in solid, and conductor in melting or solution state. Melting point is high. An example is NaCl. Then the metallic solid, so constitute positive ions, bond is metallic bond, and nature is hard. Conductivity is conductor except mercury. Then melting point is high. An example is iron, copper, and lead. Then the covalent solids, so constituents are the atom, bond is covalent bond, nature is hard except granite, conductivity conductor except dimer, and melting point very high. An example: diamond, graphite, and fluorine are the covalent solid. Then comes the amorphous solid. So arrangement: short range order, irregular, melting point range of temperature, compressibility limited, symmetricity non-symmetrical, isotropic, and supercooled liquid, glass, plastic, and rubber. Then comes the interparticle force. So attraction force between particles. So accession, not attraction. So covalent bond, electron sharing, and electrostatic force, ionic attraction. Then van der Waals force. So occur between molecules. Types are dipole, bipolar. So dipole between permanent dipoles, and induced bipolar between permanent and induced dipole, and London dispersion means London force between temporarily instantaneous dipole occurs in all molecules. Then the strength dipole is very high strength, then induced dipole, then London dipole. Then the liquid state details. So vapor pressure. So in a half filled closed container at below boiling point, a liquid vaporized. Vapor puts pressure on liquid and equilibrium vaporization equal to condensation. So the boiling point. So in an open container, upper surface molecule vaporize, vapor pressure equal to external pressure, entire liquid boil. Then the critical temperature. So in a closed container, when temperature where liquid density equal to vapor density, then the application of this so lower boiling point at high altitude and pressure cooker are the application of this critical temperature and boiling point. Surface tension. So tendency of a liquid to shrink. Surface molecule pulled inward, highest force on surface molecule. Definition: force perpendicular to line of surface. So forces, cohesive forces between same molecule and adhesive forces between differential molecule. Then the application of this the capillary action and water absorbed by plant is application of this capillary and surface tension. Then the factor affecting, so increase with density and decrease with temperature. Then comes the viscosity. So viscosity is resistant to flow, friction between liquid layer moving at different speed, and definition: friction due to velocity different between layer, and the factor affecting the viscosity is increase with density and decrease with temperature. Then the gas state details. So the noble and universal gases. So 11 noble gases at normal temperature and pressure. 5 normal gases: H2, N2, O2, Cl2, F2. 6 noble gases: He, Ne, helium, neon, argon, and krypton, xenon, and rhenon are the zero valency and a full octet. Then the gas law. So relative volume and pressure and temperature and molecule. So pressure equal is so Boyle's law means the temperature. So Boyle's law, the temperature boil means if given temperature then it will boil. So temperature is constant. So volume is inversely proportional to the pressure. So curve isotherm. So then the Charles law. So the pressure is constant. So relative relation volume is directly proportional to temperature. Curve is isobar. Then the gas or Lucas law. So gas Lucas constant is when volume is constant, then P equal to T proportional to T direct, and curve is isochore. So the Charles law, the pressure Cp, and gas law V, Gv, and Avogadro law. So constant Pt and relation is V proportional to N, and Avogadro constant is K. So V equal to Kn, and K equal to 6.23 into 10 power 23 moles per volume. So this is our chemistry state of matter chapter finished. Jai Hind.